Okay, so this is a bearing problem, and sorry it's so small, so I'm just going to blow it up for a second so we can read it. We have two ships leaving the same place at a certain time. We have one going to the northwest at 12 miles an hour. And we have one going to the southwest at 16. And the question says, how far apart are they at 12 o'clock? So if they leave at 9 and they want to see at noon, that means they've traveled for 3 hours. So that's going to kind of help us in a little bit. So we first have to draw some stuff. So let's draw our port. Okay, because this is a bearing problem, I have to put a compass there with the 4 points of the compass: north, east, south, and west. Okay, so that's first off. We have one boat going to the northwest, north 53 degrees west. That means we start at north and we turn towards the west until we reach 53 degrees. And that boat is heading out this direction somewhere. Okay, this is 53 degrees. Okay, west of north, or north 53 degrees west. Now our other boat is going south 67 degrees west. So we start at the south point on your compass and you go towards the west until we reach 67 degrees. Okay, so this ship is heading in this direction. So at least we know the direction in which the ships are headed. They're headed away from each other, but not like exactly away from each other. So the question is, how far apart are they at noon? So we're going to draw in this distance here. That is how far apart they are. So that's what we're going to try to find. Okay, so since this is a law of sines and cosines thing, we need to know this angle right here. Okay, because law of sines requires us to know some opposite sides and angles. And we can also find an opposite side if we know the angle using the law of cosines. Okay, so right now we don't know enough information for either one of those two things, but we can figure out some distances. So how far has our red ship traveled? If it travels at 12 miles an hour, from 9 until noon, okay, is 3 hours. Sorry, that's not minus, but that's 9 till noon. It's 3 hours. That means this ship has traveled 36 miles in that 3-hour time span. So we know that that length, or that distance, is 36. Similarly, we can do the same thing with our blue ship that's traveling at 16 miles an hour. It also traveled for 3 hours, meaning it has traveled 48 miles in those 3 hours. So now we know two sides of our triangle, and all we need to do is figure out what this angle right here is. Okay, and to do that we use some geometry. We notice that from the north to the south is 180 degrees. Hopefully you know that. And if we subtract off 53 degrees from up there and 63 degrees from down there, we find that this angle here is 60 degrees in between your ships. Okay, that's an important degree to know. In between your ships is 60, because now I know the angle across from what I want to find. Okay, so if I know a side and then an angle and then a side, this is a great problem for the law of cosines in order to solve. Okay, so law of cosine says x squared equals, okay, we will square the other two lengths that we know. We will subtract 2 times 36 times 48 times the cosine of the angle across. So because we're looking for x, we use 60 degrees in our law of cosines. When I plug all this into my calculator and then take the square roots at the end, I get 43.3 miles is the distance in between the ships at 12 o'clock.